Russia operates one of the world's most formidable military forces, with over 1.3 million active personnel, a defense budget that's tripled since 2000, and a nuclear arsenal matching America's. But could this massive war machine actually stop a full scale US invasion? This is every major weapon system operated by the Russian ground forces. We start our list with tanks. T-14 Armata. This is Russia's answer to every Western tank designer who thought they knew what next generation armor looked like. Unveiled in 2015, with an unmanned turret, crew capsule in the hull, and active protection systems that supposedly intercept incoming missiles before they hit. The Armata was meant to replace everything, except Russia's built maybe 100 of them total because each one costs between $5 and $8 million, and the engine doesn't work right. The A-85 3 power plant was designed for buses, not 5 5-ton tanks, and it breaks down so often that these supposedly revolutionary machines barely leave the factory. Russia claims they're in service. Reality says they're too expensive to risk in Ukraine, where a $2 million Javelin would turn an $8 million tank into scrap metal. T-90M Proriv. When your wonder weapon costs too much and doesn't work, you upgrade what you've got. The T-90M takes the proven T-90 chassis and adds everything the Armata promised to deliver. Thermal sights that actually function, improved armor, and a fire control system that can engage targets while moving. Russia's producing 60 to 80 of these per year from the Ural-Vagonzavod plant, which sounds impressive until you realize they lost over 1,500 tanks in Ukraine and need these to plug holes in decimated armored units. The M variant represents Russia's realistic approach to modern warfare. Forget revolutionary, just make what works work better. T-90. The base model that's been Russia's main battle tank since the 90s brings a 125 smoothbore gun, composite armor, and the Shtora active protection system that's supposed to jam incoming missiles. It's basically a T-72 that grew up, got better optics, and learned some new tricks. Reliable enough that export customers from India to Algeria bought hundreds, but aging fast in an era where Western tanks are packing better everything. T-80BVM. This is what happens when you take Cold War gas turbine technology and try to drag it into the 21st century. The turbine engine drinks fuel like an alcoholic at an open bar, hitting 1250 horsepower, but needing constant feeding. Russia's been pulling these out of storage and slapping on reactive armor, new optics, and hoping they can survive modern anti-tank weapons. They're fast, they're loud, and Ukrainian farmers have been towing abandoned ones away with tractors because gas turbines are maintenance nightmares. T-80 UNT 80 BV. Earlier variants of the gas turbine tank that are still being dragged out of storage and refurbished because Russia needs anything with tracks and a gun. The U model brought improved armor and fire control in the 80s, while the BV added explosive reactive armor blocks. Both are obsolete by modern standards, but still dangerous when properly crewed. T-72B3 and B3M. These Soviet-era workhorses have been the backbone of Russian armored forces for decades, and they're still here because Russia's got thousands in storage. The B3 upgrades add thermal sights, better armor, and fire control systems, while the B3M goes further with improved engines and electronics. Ural-Vagonzavod processes about 200 of these per year, from stored hulls, refurbishing tanks that first rolled off assembly lines when Brezhnev was still alive. They're outdated, underprotected, and vulnerable to modern weapons. But Russia's using them because they've got them, and building new tanks from scratch costs money Moscow doesn't want to spend. T-72B, the basic variant that defines Soviet armored doctrine for a generation, cramming a 3-man crew into a tight space with an autoloader that sometimes turned into a death trap when penetrated. Millions of rounds of stored ammunition cooking off inside a tank makes for spectacular turret-tossing explosions. These older models lack the upgrades that make their cousins semi-relevant, and they're being pressed into service because Russia's running out of better options. T-64BV, the Ukrainian-designed tank that Russia inherited after the Soviet collapse and never really loved. It's got the same carousel autoloader vulnerability as other Soviet designs, and spare parts are a nightmare because production moved to Ukraine. Russia's using whatever T-64s remain operational, but they're at the bottom of the priority list for upgrades. T-62M. When you're so desperate for tanks that you're pulling Cold War relics from the 1960s out of storage, you know the situation's bad. The T-62M represents modernization attempts on a platform that should be in museums. Adding reactive armor and fire control to a 152 showed up, but Russia's got hundreds sitting in depots, and a bad tank beats no tank. T-55, these ancient machines from the 50s are still showing up in storage depots and getting refurbished for rear area security or sold to whoever's buying. The 100 gun is a joke by modern standards. The armor won't stop anything more advanced than heavy machine guns, but they run and somebody somewhere thinks they're worth maintaining. Moving on to infantry fighting vehicles and armored personnel carriers. BMP 3. Russia's most modern IFV brings a 100 gun, a 30 autocannon, and an anti-tank missile launcher, basically a light tank masquerading as a troop carrier. The theory's solid, give infantry serious firepower while keeping them protected. Reality's messier because cramming that much weaponry into an aluminum box means armor's thin and internal space is cramped. It floats, which matters for river crossings, but Ukrainian drones don't care about amphibious capability. BMP-2M. Take the older BMP-2 and slap on a Bergerac turret with modern anti-tank missiles and improved fire control. The M variant keeps thousands of legacy vehicles relevant by giving them the ability to engage modern armor at extended ranges, though the basic aluminum hull still can't stop much. BMP-2, the Cold War standard that armed Soviet motor rifle divisions from the 70s onward, mounting a 30 autocannon and space for 7 infantry in the back. These aluminum boxes were meant to keep pace with tanks while providing fire support, and they did that job well enough that Russia's still using thousands. Modern warfare's made them obsolete because armor protection that worked against rifle fire doesn't stop javelins or even RPGs. BMP-1, the original that started the IFV concept in the 60s, armed with a 73 gun that's more suggestion than precision weapon. Russia shouldn't still be using these, but storage depots are full of them, and desperate times call for desperate measures. They're getting pulled out, refurbished, and sent to units that need anything with tracks. BMD 4M. Airborne forces demanded something that could drop from planes and still fight. And the BMD 4M delivers with a 100 gun, 30 autocannon, and the kind of weight discipline that lets it deploy with VDV units. It's lightly armored because physics won't let you drop heavy armor from aircraft, but for air assault operations, where getting there first matters more than surviving sustained combat, it works. BMD 2. The older airborne fighting vehicle that's been dropping with Russian paratroopers since the 80s. It's got a 30 autocannon and can swim, which matters when you're landing in unpredictable terrain, but the armor's so thin that dedicated anti-armor weapons turn it into scrap. BTR-82A. Wheeled armored personnel carriers give Russia tactical mobility on roads where tracked vehicles would tear up pavement. The 82A mounts a 30 autocannon in an unmanned turret, improving on decades of BTR designs that just moved infantry without providing serious fire support. 8 wheels mean it's fast, relatively fuel efficient, and easier to maintain in tracked vehicles, though easier is relative when you're dealing with Soviet-era automotive technology. BTR-80, the predecessor that's been hauling Russian infantry since the 80s, mounting a 14.5 heavy machine gun and seating for 7 troops, plus a 3-man crew. It's simple, it's reliable in the way Soviet military equipment is reliable, meaning it breaks regularly but can be fixed with a hammer and some creativity. And it's still everywhere because Russia built thousands. BTR-60. These ancient 8-wheeled boxes date back to the 60s and should be in museums, not combat zones. But Russia's inventory depth means even obsolete vehicles get pressed into service when modern production can't keep pace with losses. BTR-MDM, the airborne version of the BTR family, airdroppable and amphibious for VDV operations. It's cramped, it's light, and it provides just enough protection and firepower for paratroopers who need mobility more than heavy armor. Tank support combat vehicles exist because modern infantry with anti-tank weapons kept blowing up Russian armor in Chechnya. The Terminator mounts dual 30 autocannons, grenade launchers, and anti-tank missiles on a T-72 chassis, designed to suppress infantry threats, while tanks focus on enemy armor. It's specialized, expensive, and produced in tiny numbers because Russia can barely afford to make tanks, let alone support vehicles. MTLB. This multi-purpose tracked vehicle has been doing everything from hauling infantry to carrying supplies to mounting weapon systems since the 70s. It's lightly armored, basically aluminum skin over a diesel engine, but it's simple enough that field mechanics can keep them running and versatile enough that desperate armies find uses for them. Typhoon K and Typhoon U. When IEDs became a problem in the North Caucasus and Syria, Russia developed mine-resistant vehicles. The Typhoon family provides blast protection and crew survivability for convoy operations, with different variants for different roles from troop transport to command and control. The V-hull design saves lives when the vehicle hits a mine. Tiger and Tiger M, light armored vehicles for reconnaissance, patrol, and special operations. Basically Russia's answer to the Humvee. They're better protected than soft-skin vehicles, but still vulnerable to anything heavier than small arms. Various weapons can be mounted, from machine guns to grenade launchers to anti-tank missiles. Moving on to artillery. 2S-19 MSASS. This 152 self-propelled howitzer, automated loading, shoot-and-scoot tactics, and the ability to rain high-explosive death from 30 kilometers away. Tracked chassis means it can keep up with mechanized formations, and the automation lets crews fire multiple rounds, then displace before counter-battery radar figures out where they were shooting from. 2S-35 Koalitsiya SV. Russia's newest self-propelled artillery promises automated fire control, 70-kilometer range with rocket-assisted projectiles, and the ability to put multiple rounds on target simultaneously. Production numbers are unknown because even Russia's defense ministry doesn't broadcast how many next-generation weapons they're actually building versus how many they're planning to build someday. 2S-3 Akatsiya, the older 152mm self-propelled gun that served Soviet artillery units from the 70s onward. It's being replaced, but still shows up because Russia's artillery-centric doctrine demands maximum tubes firing, regardless of how old those tubes are. 2S-1 Gvozdika, a 122mm self-propelled howitzer mounted on an MTLB chassis, giving Soviet airborne and motor rifle units organic fire support. Light enough to be airdroppable in theory, though in practice, these mostly support conventional ground forces. 2S-7 Peon. This 203mm self-propelled gun is what happens when you decide that 152mm isn't enough, and you need to throw shells the size of trash cans at the enemy. The Peon's massive and slow, but when you need to destroy hardened fortifications or blast through urban positions, nothing else has the payload. 2S-4 Tilepen. The 240mm mortar system that launches rounds so heavy they blur the line between mortar and artillery. High-angle fires let it hit targets and defilade that conventional guns can't reach. Perfect for urban warfare and fortified positions. 2S-9 Nona. Light airborne artillery that can fire both mortar rounds at high angles and direct-fire anti-tank rounds, giving VDV commanders organic fire support that deploys by parachute. It's amphibious and light enough for air assault operations. 2S-5 Gyatsint S. Long-range 152mm self-propelled gun that reaches out past 33 kilometers with standard ammunition. It's older than the MSTA, but still capable. And Russia keeps using them because artillery tubes that work don't need replacing. 2S-31 Vina. This 120mm gun mortar system mounted on a BMP-3 chassis gives mechanized units organic fire support that can keep up with armor. It combines the high-angle capability of mortars with the precision of guns. D-30 and D-20. Towed howitzers from the 60s and 70s that are still doing the job because artillery tubes don't care how old they are as long as the barrel's straight and the breech works. They lack the mobility and protection of self-propelled systems, but they're cheap, simple, and Russia's got thousands sitting in storage. D-1, ancient 152mm howitzer, dating back to World War II that somehow keeps showing up in reserve units and militias. It's obsolete by every measure except does it shoot, and the answer's still yes. BM-21 Grad, the multiple rocket launcher that made rocket artillery a household term during every conflict since Vietnam. 4,122mm rockets fired in 20 seconds will ruin anyone's day. And the Grad's simplicity means crews can reload and fire again fast enough to saturate target areas before anyone can respond. Accuracy's terrible, but that's the point. You're not precision striking, you're blanketing grid squares with high explosive. BM-27 Uragan, heavier rocket system firing 220 mmR rockets that trade the Grad's volume of fire for individual rocket payload and range. 16 tubes reach out to 35 kilometers with warheads that include high explosive, cluster munitions, and incendiary options. BM-300 NMA rockets that reach 90 kilometers away. This multiple launch rocket system delivers devastation that single howitzers can't match. 12 tubes launch in rapid succession, covering target areas with high explosive, cluster munitions, or thermobaric warheads, and a full salvo delivers enough explosive to level anything unfortunate enough to be in the impact zone. 9K-58 Tornado S. Upgraded version of the Smerch with improved guidance and range, representing Russia's effort to modernize rocket artillery without designing completely new systems. Better accuracy means fewer rockets wasted on empty ground. 9K-57 Tornado G. The Grad replacement that's slowly entering service with modern fire control and improved rockets. It maintains the basic concept of massed fires while adding 21st century electronics. TOS-1A Solon Spec. This thermobaric rocket launcher doesn't just explode, it creates fuel-air mixtures that ignite and consume oxygen across the blast radius. The result's a weapon that clears fortified positions, caves, and urban strongpoints by literally burning the air. It's devastating, it's terrifying, and it's mounted on a T-72 chassis so it can roll up to the front line and deliver hell before anyone realizes what's happening. TOS-2 Tosochka. Newer version of the thermobaric system mounted on a Ural truck instead of a tank chassis, making it cheaper to produce and operate. Still brings the same pressure wave death to fortified targets. Moving on to air defense. S-400 Triumph. Russia's most advanced long-range air defense system can engage aircraft, cruise missiles, and ballistic missiles out to 400 kilometers with the right interceptors. Sophisticated radar, multiple missile types for different threat profiles, and the ability to coordinate with other defense systems make this the centerpiece of Russia's integrated air defense network. Western Air Force is respected enough to plan entire missions around avoiding its engagement envelope. S-500 Prometheus. the next generation system that's supposed to engage hypersonic missiles, satellites, and ballistic missiles at ranges and altitudes the S-400 can't reach. Production's limited, deployment's gradual, and whether it works as advertised won't be known until someone actually tries to shoot something down with it. S-300V4 and S-300OPM, the predecessors to the S-400, that are still deployed across Russian military districts because you don't retire working air defense systems when they're still capable of shooting down aircraft. The V4 focuses on ballistic missile defense, while the PM handles aircraft and cruise missiles, and both have been upgraded enough times that they remain relevant threats. S-350 Vityaz, medium-range system filling the gap between short-range point defense and long-range strategic systems, providing mobile air defense for military formations and critical infrastructure. Modern digital systems and improved reaction times make it effective in the envelope, where older systems are being phased out. Buck M3, medium-range air defense fills the gap between tactical systems and strategic defenses, engaging targets from 2.5 to 70 kilometers depending on missile variant. Mobile, quick to deploy, and lethal enough that aircraft stay outside its range when possible. Book M2, the earlier variant that's still widely deployed because Russia built hundreds and they still work. Tracked launchers let it operate in terrain where wheeled systems would bog down, and the radar can handle multiple targets simultaneously. Tor M2, short-range air defense designed to protect ground forces from aircraft, helicopters, and cruise missiles. Operating at low altitude, the Tor can engage targets on the move, making it ideal for protecting advancing formations or mobile command posts. Radar tracks dozens of targets while engaging multiple threats nearly simultaneously. Tor M1, earlier version that's still protecting units that haven't received the M2 upgrade. It's effective within its envelope, though the electronics are showing their age. Pantsir S1, combined gun and missile system, brings 30mm autocannons for close-in targets and surface-to-air missiles for everything else. It's supposed to protect S-400 batteries from saturation attacks, shooting down incoming missiles before they can hit the bigger, more valuable air defense systems. Gun ammunition's cheap compared to missiles, which matters when you're shooting at expendable drones. Pantsir SM, upgraded variant with extended range missiles and improved radar, representing Russia's continuous improvement approach to point defense. 9K-35, Strela 10, aging short-range air defense that's been around since the 70s, mounted on MTLB chassis for mobility. It's basic, the missiles are infrared-seeking and limited to visual range targets. But infantry fighting vehicles and helicopters still go down when these fire. 9K-22 Tunguska. This self-propelled anti-aircraft weapon combines 30mm autocannons with surface-to-air missiles on a tracked chassis. The guns engage low-flying aircraft and helicopters, while missiles handle targets beyond gun range. It's been around since the 80s but remains effective for point defense. Tunguska M1, modernized version with improved fire control and better integration with networked air defense systems, keeping the basic platform relevant. 2. K-22M Sosna, light air defense system designed for rapid reaction against helicopters, drones, and ground attack aircraft. Laser-guided missiles give it precision that earlier infrared systems lacked. 96K6, Pantsir S2, Arctic variant of the Pantsir, designed to operate in extreme cold where other systems would freeze. Russia's northern territories demand equipment that works at temperatures that would kill conventional electronics. Moving on to fighter aircraft. Su-57 Felon, Russia's fifth-generation stealth fighter, was supposed to match the F-22 and dominate Eastern European skies. Limited production, maybe 20 to 25 aircraft total as of 2024, means it's more technology demonstrator than operational fleet. The Su-57 brings reduced radar cross-section, supercruise capability, and advanced avionics. But sanctions have limited access to Western electronics, and manufacturing delays have prevented mass production. It's flying combat missions in Ukraine from safe Russian airspace, launching long-range missiles without entering contested zones, which tells you everything about Russian confidence in its survivability. Su-35S Flanker E. When your fifth-generation program's too expensive and slow, you build more of what works. The Su-35S takes the proven Su-27 Flanker airframe and adds thrust vectoring engines, modern radar, and weapons integration that make it a legitimate threat. Russia's producing about 10 per year from the Komsomolsk-on-Amur plant, and these are seeing heavy use in Ukraine for air superiority and ground attack missions. It's not stealthy, it's not fifth generation, but it's capable and available. Su-300SM and SM-2, multi-role fighters optimized for long-range strike and air-to-air combat, bring two-seat configuration for pilot and weapons system officer. The SM-2 variant adds improved avionics and weapons compatibility, and Russia's using these across their air force for everything from fleet defense to ground attack. About 110 total in inventory, means they're common enough to matter. Su Tu-7SM and SM-3. Upgraded versions of the original flanker that keep older airframes relevant, while Russia waits for enough new-build Su-35s to replace them. The SM-3 brings modern radar and weapons compatibility to a platform that first flew in the 80s. Su-27, the original flanker that defined Soviet fourth-generation fighters in the 80s, bringing incredible maneuverability, long range, and a weapons load that made it a credible threat to Western air superiority. Hundreds are still flying in various upgraded forms because Russia never throws away functional aircraft when they can be modified and kept operational. MiG-31BM. This Cold War interceptor was built to shoot down American bombers before they could reach Soviet territory, flying at Mach 2.8 and carrying long-range air-to-air missiles. Russia's updated the fleet with modern avionics and weapons compatibility. And now, these serve as platforms for Kinzhal hypersonic missiles, turning interceptors into strategic strike assets. MiG-31K, the Kinzhal carrier variant that's been launching hypersonic strikes in Ukraine. It sacrifices some fuel capacity for the massive missile pylon, but when you're carrying a weapon that goes Mach 10, the trade-off makes sense. MiG-29SMT and MiG-29UB. Like tactical fighters that supported Soviet frontal aviation for decades, optimized for short-range air superiority and ground attack. They're obsolete by Western standards, but Russia's still flying them because they're cheap to operate and maintain compared to larger, more capable platforms. MiG-35, the latest Fulcrum variant that was supposed to modernize the MiG-29 line with AESA radar, improved engines, and better weapons integration. Limited production means it's more proof of concept than operational backbone. Moving on to attack and bomber aircraft. Su-34 Fullback. This tactical bomber became Russia's workhorse strike aircraft, conducting thousands of sorties in Syria and Ukraine. The side-by-side cockpit gives pilot and navigator/weapon systems officer room to work, and the aircraft carries everything from dumb bombs to precision-guided munitions to anti-ship missiles. Russia's producing 12 to 14 per year in the Su-34M configuration with upgraded avionics and weapons, trying to replace combat losses while expanding the fleet. When you see videos of Russian glide bombs hitting Ukrainian positions, there's a good chance a Su-34 delivered them. Su-25 SM-3. The latest Frogfoot variant brings modern targeting pods, precision weapons compatibility, and improved survivability to close air support missions. It's still slow, still vulnerable, but the armor around the cockpit and redundant systems mean these keep flying even after taking hits. Su-25. Close air support aircraft designed to operate from rough forward airfields while supporting ground forces, mounting heavy armor around the cockpit and vital systems. It's slow, it's vulnerable to modern air defense, and Russia keeps using them anyway, because combined arms doctrine demands organic air support even when it's costly. Su-24M and Su-24M2. Supersonic strike aircraft from the 70s that's been bombing things for Russia since Afghanistan. Variable sweep wings give it performance flexibility, and modernized electronics keep it marginally relevant. But it's old, it shows, and newer platforms are replacing it when possible. 160M. This massive strategic bomber is Russia's equivalent to the B-1, supersonic speed, variable sweep wings, and the ability to carry cruise missiles or nuclear weapons across intercontinental ranges. The M variant brings modernized avionics and engines to airframes that date back to the Cold War. Only a handful are operational because they're incredibly expensive to fly and maintain, but they serve as highly visible symbols of Russian strategic power. 160. The original blackjack that's still flying after decades of service. Some are being upgraded to M standard, while others soldier on with their original systems, launching cruise missiles from safe standoff ranges. 95MS and MSM. The turboprop strategic bomber that's been flying since the 50s and somehow still in service because Russia keeps upgrading the avionics and weapons while the basic airframe just keeps working. It's subsonic, it's loud enough that Western fighters can hear it coming from hundreds of miles away, but it carries cruise missiles that can strike from standoff range. And that's what matters. The MSM variant carries more missiles and has better electronics. 22M3 and M3M. Supersonic medium-range bomber, designed for theater strike missions, combining speed with payload capacity for attacking naval and ground targets. Russia's been using these in Ukraine and Syria, and they're effective when operating from protected airspace with fighter escort. The M3M upgrade brings modern navigation and weapon systems. Moving on to support and special mission aircraft. Il-76MD and MD-90. Strategic airlifter that's been moving Russian military cargo since the 70s. 4 turbofan engines lifting 50 tons of equipment or 140 troops across intercontinental distances. The MD-90A brings modern avionics and Russian-built engines to reduce foreign dependency. It's not glamorous, it's not modern, but logistics win wars, and the Il-76 keeps Russian forces supplied wherever they deploy. 124 Ruslan, the massive strategic airlifter that can swallow tanks and armored vehicles whole, moving outsized cargo across global distances. Only a handful remain operational because maintenance is expensive and complex, but they provide capability Russia can't replicate with anything else. When you need to move something that won't fit in an Il-76, this is the only option. And 1-2, the older turboprop transport that's still hauling cargo for second-line units. It's slow. It carries less than the Il-76, but simplicity keeps some flying for missions where jets would be overkill. An 2-6, smaller tactical transport for short-haul logistics and regional movements where larger aircraft aren't needed. Light cargo and personnel move on these to places that can't support jet operations. An 7-4, SDOL transports designed for operating from unprepared airstrips in remote locations. The engines mounted above the wings create additional lift, letting them operate from runways that would be too short for conventional transports. 50U and A-50, airborne early warning and control aircraft based on Il-76 airframe, mounting a rotating radar dome and mission systems for detecting and tracking aircraft across hundreds of kilometers. Russia's got maybe 8 operational after Ukrainian strikes destroyed several, and losing these hurts because they're irreplaceable with current production capacity. The U variant brings improved radar and processing. 214 R, reconnaissance aircraft equipped with signals intelligence and surveillance systems for collecting electronic emissions and imagery. Limited numbers mean they're deployed carefully, gathering intelligence without risking expensive, hard-to-replace platforms. Il-20M, electronic intelligence aircraft based on Il-18 turboprop, collecting signals intelligence along NATO borders and conflict zones. It's old, it's slow, but the mission equipment works, and electronic emissions don't care about the platform collecting them. Il-22M, airborne command post for nuclear forces, maintaining communications between leadership and strategic bombers during crisis. The mission's critical enough that obsolete airframes keep flying because replacement would cost billions. Il-78M, aerial refueling tankers that extend the range of Russian combat aircraft, based on Il-76 transport with refueling pods and systems. Russia's tanker fleet is small compared to American aerial refueling capability, limiting their ability to sustain long-range combat operations. The M variant has improved systems. Il-78M90, newest tanker variant with modern avionics and engines, slowly entering service to replace older Il-78s that are literally falling apart from age and overuse. Moving on to helicopters. Mi-28NM and Mi-28N Havoc. Attack helicopter optimized for anti-armor operations, brings 30mm cannon, anti-tank missiles, and rockets for engaging ground targets. The NM variant adds upgraded avionics, improved sensors, and better integration with modern precision weapons. It's Russia's answer to the Apache, though in practice it's less capable and more vulnerable than Western propaganda suggests, while being more effective than Western analysts admit. Ka-52M and Ka-52 Alligator. This coaxial rotor attack helicopter doesn't need a tail rotor, making it more compact and maneuverable. It's been Russia's primary attack helicopter in Ukraine, and they're losing them steadily to manpads and air defense because flying low and slow near modern infantry is suicide even with armor. The M variant brings improved weapons and sensors, assuming they can build enough to replace losses. Ka-52K Katran, naval variant designed to operate from ships with folding rotors and corrosion-resistant components. The Mistral carriers they were designed for never arrived, but the helicopters exist anyway. Mi-24P and Mi-35M Hind, the flying tank that's been terrorizing infantry since the 70s, combines troop transport with attack helicopter firepower. The P variant swapped the flexible gun for a fixed 30mm cannon, while the M brings modern avionics and weapons. It's obsolete, it's vulnerable, and Russia keeps using them because they've got hundreds and modern production can't keep pace with demand. Mi-8A MT-SHA, MTV-5, and MTPR-1. Utility helicopters doing everything from troop transport to medevac to assault operations. Basic rotary wing workhorses that show up everywhere Russian forces deploy. The SHA variant adds armor and weapons for combat operations. The MTV-5 focuses on transport, and the MTPR-1 is an electronic warfare variant for jamming enemy communications. Mi-8 MTV-5-1, upgraded transport variant with improved engines and avionics, capable of operating in extreme conditions from Arctic to desert. Mi-26 Halo, the world's largest production helicopter, can lift 20 tons of cargo, or 90 troops, providing heavy lift capability that nothing else in Russian inventory can match. Limited numbers mean they're reserved for missions requiring their unique capability, like recovering downed aircraft, or moving artillery pieces. Mi-17V-5, export variant of the Mi-8 that's also used by Russian forces, bringing tropical climate modifications and improved performance in hot and high conditions. Ka-27 and Ka-29 Helix. Naval helicopters operating from Russian warships conducting anti-submarine warfare, search and rescue, and assault transport missions. The coaxial rotors reduce folded dimensions for shipboard storage while maintaining performance in maritime conditions. Ka-31 Helix. Airborne early warning variant with a rotating radar antenna under the fuselage, providing fleet air defense radar coverage from helicopters operating off cruisers and carriers. Mi-14 Haze. Amphibious anti-submarine helicopter that can land on water, though most have been retired in favor of Ka-27 variants that don't need the complexity of boat hull. Ansat and Ansat U. Light utility helicopters for training, medical evacuation, and liaison missions. The U variant is optimized for pilot training. Ka-226. Light helicopter for observation, liaison, and training missions. Civilian origins make it cheaper to operate than dedicated military helicopters for low-threat missions. Moving on to unmanned aerial vehicles. Orion. Eno Kodets. Russia's first domestically developed armed drone carries guided missiles and bombs for strike missions. It's years behind Turkish and American equivalents in capability and reliability, but it represents Russia's attempt at modern unmanned strike capability. Production's limited, deployment's gradual, and its learning curve's been paid in lost aircraft. Orion 2. Improved variant with better endurance and payload, slowly entering service as Russia figures out how to build and operate armed drones at scale. Forepost and Forepost R. Licensed production of the Israeli Searcher UAV provides tactical reconnaissance for ground forces. The R variant adds domestically produced components to reduce foreign dependency after sanctions complicated spare parts. Orlan. This small reconnaissance drone has become Russia's primary tactical UAV, launched from a catapult and recovered via parachute. It provides battalion and brigade level commanders real-time video of enemy positions, but it's primitive compared to Western equivalents, and Ukrainian forces have shot down hundreds. That doesn't stop Russia from building more because cheap and expendable beats sophisticated and scarce. Orlan 3.0. Larger variant with improved sensors and endurance extends reconnaissance capability, while maintaining the basic Orlan concept of cheap, expendable tactical intelligence. Zala Lancet 1 and Lancet 3. Loitering munitions that have proven devastatingly effective in Ukraine, hovering over battlefields until operators identify targets, then diving into impact. The Lancet 3 is larger with more explosive, while the Lancet 1 is cheaper and easier to produce in volume. Cheap enough to mass produce, sophisticated enough to find and hit targets, and effective enough that Ukrainian forces consider them a major threat. QBBLA and QBE, another loitering munition family designed to saturate defenses with numbers rather than sophistication. Different variants carry different warhead sizes for different targets. Aileron 3 and Aileron 1.0. Small tactical reconnaissance drones for company and battalion level reconnaissance, hand-launched and operated by frontline units needing immediate intelligence. Simple enough that infantrymen can use them. Cheap enough that losses don't matter. Granat series. Family of tactical reconnaissance UAVs for artillery spotting and target acquisition, helping Russian forces improve indirect fire accuracy with real-time video. Helibos and Tachyon. Small quadcopter drones adapted for dropping grenades and small munitions, representing Russia's embrace of commercial drone technology for military purposes. Merlin VR. Portable reconnaissance drone for special forces and reconnaissance units, providing covert surveillance without the signature of larger systems. Corsair. Tactical UAV for real-time reconnaissance and target designation, filling the gap between small hand-launched drones and larger theater-level systems. Moving on to electronic warfare systems. Krasuka 4 and Krasuka 2. Ground-based electronic warfare systems designed to jam airborne early warning and control aircraft, disrupt satellite communications, and degrade enemy targeting radars. The Krasuka 4 is mounted on Bayes chassis for mobility and creates electronic protection zones around advancing forces. While the Krasuka 2 focuses on suppressing airborne radars, the theory's solid, deny the enemy their sensors, and their precision weapons stop working. Reality's messier because modern systems use frequency hopping and countermeasures. RB 301, Biborysoglepsk. 2. Automated jamming station targeting enemy communications and radio networks at tactical level. 4 vehicles work together to locate, classify, and suppress enemy transmissions across multiple frequency bands simultaneously. When it works, enemy units go deaf and blind. Moskva 1. Tactical electronic warfare system, mounted on NTLB chassis, brings frontline jamming capability to Russian ground forces, disrupting enemy communications and radio-controlled weapons at ranges up to 30 kilometers. Lear 3. UAV-based electronic warfare system, using Orlan drones equipped with jamming pods to suppress enemy communications while airborne. The drones orbit over target areas broadcasting jamming signals across cellular and radio frequencies. Jitel. Vehicle-mounted jammer for suppressing radio-controlled IEDs and drones, protecting convoys from remote detonated explosives. RB 636 Svetq and RB 109A Belina. Tactical jamming systems for disrupting enemy communications and data links at brigade and division level. 1 RL 257 Krasuka S4. Mobile electronic warfare system for protecting air defense sites from anti-radiation missiles by jamming enemy targeting radars. Moving on to engineering and support vehicles. IMR 2EM and IMR 3 EM. Combat engineering vehicles based on T-72 and T-90 chassis bring bulldozer blades, manipulator arms, and mine-clearing equipment for obstacle breaching under fire. The M variants add modern hydraulics and improved tools while maintaining armor protection that survives small arms and artillery fragments. IMR 2MA. Arctic variant designed to operate in extreme cold, with heated hydraulics and cold weather starting systems. BAT 2. Armored bulldozer on tracked chassis provides heavy earth-moving capability for constructing fortifications, clearing obstacles, and creating fighting positions. Based on civilian heavy equipment with armor added, it's slow but effective at reshaping terrain. MTU 7.2 and MTU 9.0. Armored bridge layers, based on T-72 and T-90 chassis, carry scissoring bridges that deploy in minutes, spanning gaps up to 18 meters. The MTU 9.0 is newer with improved hydraulics and faster deployment. TMM 3M and TMM 6. Truck-mounted bridge systems for crossing wider gaps, deploying 40-meter spans that handle 6 zero-ton vehicles. Multiple trucks work together for even wider crossings. PMP and PP 2005. Pontoon bridge systems transported by trucks and assembled into floating roadways for crossing rivers too wide for tank-launched bridges. The PP 205 is the modern version with improved pontoons and faster assembly. PMM 2. Heavy mechanized bridge mounted on CRAS truck chassis provides tactical bridging for routes where permanent structures have been destroyed. BREM 1 and BREM 2. Armored recovery vehicles based on T-72 and T-90 chassis bring cranes, winches, and repair equipment for recovering damaged tanks under fire. Every armored formation needs these because tanks break down, get stuck, and get damaged. MTP A2 1. Technical support vehicles based on MZKT chassis carry spare parts, repair equipment, and trained mechanics for conducting field repairs on damaged vehicles. TMS 6.5. Bridge erection boat for river crossings, capable of transporting and positioning pontoon sections under fire. GMZ 3. Mine-clearing vehicle based on MTLB chassis with plows and rollers for clearing paths through minefields. It's slow, it's vulnerable, but somebody has to go first. UR 77 Meteorite. Mine-clearing system that fires line charges into minefields, then detonates them, clearing a path with explosive force. Mounted on tracked chassis for mobility. BMR 3 Vepr. Modern mine-clearing vehicle based on T-90 chassis with improved plows, rollers, and trawls for breaching obstacles under fire. Moving on to Air Defense Command and Control. 55Z6M NEBO M. Multi-band radar system combining VHF, L-band, and UHF arrays to detect stealth aircraft by watching for radar signatures that low-frequency systems can pick up even when higher-frequency radars see nothing. It's Russia's answer to F-22 and F-35 stealth, trading precision tracking for detection capability. 1. L119. NEBO SVU. Mobile 3D VHF radar for detecting cruise missiles and aircraft at low altitude, mounted on a single vehicle for rapid deployment. Low-frequency radar sacrifices accuracy for detection range and resistance to jamming. Podlet K1. Low-altitude radar designed to detect threats flying below traditional air defense coverage, filling gaps that aircraft exploit when penetrating integrated air defense systems. Gamma S1 and Gamma DE. Mobile radar systems for detecting cruise missiles, drones, and helicopters. Operating at ultra-low altitude, Russia learned in Syria that small drones and cruise missiles flying low enough can bypass traditional air defense. 67N6. eBaikal 1ME. Mobile 3D surveillance radar for air defense networks, providing target tracking data to SAM systems. 96L6E. Acquisition radar for S-300 and S-400 systems, detecting and tracking targets for engagement. Opponent G and Opponent GE. Mobile jamming systems for protecting air defense sites from anti-radiation missiles by creating false targets and jamming enemy sensors. Moving on to logistics and support. Ural 43200 and Ural Next. The 6x6 general-purpose trucks that have been hauling Russian military cargo since the 70s continue serving because trucks don't need to be sophisticated, they need to be reliable and easy to fix. The Next variant brings modern cab and improved reliability to the proven chassis. COM AZ 6350, 6560, and 65225. The COM AZ family of 8x8 heavy trucks forms the backbone of Russian ground logistics, used for everything from cargo transport to mounting air defense systems to carrying supplies across terrain, where roads are suggestions rather than infrastructure. COM AZ 6560M, Arctic variant with heated fuel systems and cold weather starting equipment for operations in Siberian conditions. MZKT 7930 and MZKT 79221, heavy-wheeled transporters for strategic missiles and oversized cargo, providing Belarus-built chassis for Russia's most important mobile systems. Sanctions complicate replacement, but existing fleets keep operating. BAZ 6402, 69096, and 6910, heavy artillery tractors and transporters for towing large guns and moving air defense systems. Different variants handle different weight classes. 9. Mobile fuel distribution trucks based on Ural and Kamuzu chassis keep armored and mechanized formations supplied with diesel and gasoline in forward areas. Fuel logistics determine operational range. TPZ 5. Fuel trailer system for extending fuel truck capacity, towed behind trucks for bulk fuel distribution. AC5 600 and AC100 600. Airfield refueling trucks for servicing aircraft, providing filtered fuel and pressure pumping. BZ 6950. Tank truck for hauling water and other fluids, essential for sustaining forces in areas without local water sources. Kitchen trailers and field bakeries. Mobile food preparation equipment that keeps troops fed in the field. They're unglamorous, but armies march on their stomachs. Moving on to command and communications. R-149 MA1 and R-149 AKSH-1. Mobile command posts based on BTR-80 and MTLB chassis bring secure communications, digital mapping, and coordination capability to battalion and brigade commanders. They're supposed to provide network-centric warfare coordination, though Ukrainian electronic warfare demonstrates Russian communication security isn't what Moscow claims. R-16605 and R-6825U. Ultra-shortwave radios for tactical communications at company and platoon level. Frequency hopping to resist jamming and interception. Basic infantry radios that work when more sophisticated systems get jammed. OSART, R-187P1. Digital radio system designed to provide encrypted tactical communications resistant to interception and jamming. Russian forces in Ukraine demonstrated that in practice, they often use unsecured commercial radios because issue equipment either doesn't work or isn't available. P-260T and P-1630. 1. VHF radio systems for long-range communications between headquarters and subordinate units, necessary for coordinating operations across the distances. Russian military doctrine demands. R-423. 1. HF radio for very long-range communications when other systems are out of range or disabled. REDUT 2US and REDUT 2UM. Automated command systems for artillery fire control, integrating data from reconnaissance and sensors to coordinate fires. Strakoza. Tactical reconnaissance and target acquisition system, combining UAVs, sensors, and communications for artillery support. Moving on to chemical, biological, and radiological defense. RKM-6 and RKM-8. Radiation and chemical reconnaissance vehicles, based on BTR-80 and BRDM chassis, detect and identify chemical weapons, radiation and biological hazards in the field. Crews in full protective gear sample air and terrain to determine if areas are contaminated. TMS-65U. Decontamination vehicle equipped with high-pressure water jets and decontamination solutions for washing chemical and biological agents from personnel and equipment. Nuclear, biological, and chemical warfare remain part of Russian military doctrine, even if the reality is terrifying. ARS-14KM and ARS-12. Special reconnaissance vehicles for detecting radioactive and chemical contamination in forward areas. Based on BRDM. 2 chassis with specialized sensors and crew protection. RKHM-4, 01, and RKM-5. Older chemical reconnaissance vehicles still in service with reserve units, providing basic detection capability. DDA-66 and DDA-53. Decontamination apparatuses towed behind trucks for mass decontamination of vehicles and equipment after chemical or radiological exposure. Moving on to medical evacuation. Linza MRAP ambulance. Mine-resistant vehicle configured for casualty evacuation, brings V-shaped hull and blast protection to medical evacuation missions where IEDs and mines remain threats. It's expensive compared to soft-skin ambulances, but crews and casualties stay alive when a vehicle hits a mine. BMM 3M. Tracked armored ambulance based on MTLB chassis provides protected casualty evacuation in combat zones, where wheeled vehicles can't go. 4 stretchers plus medical equipment and medics, armored well enough to survive artillery fragments and small arms fire. Ambulance variants of Ural and Kamehameha. Soft scan ambulances for rear area medical evacuation. Where threats are minimal, they're unprotected but carry more casualties and medical equipment than armored versions. Medical modules for Me-8. Helicopter medical evacuation systems that turn transport helicopters into flying ambulances, critical for getting casualties from battlefield to surgical facilities. Moving on to naval forces. Admiral Kuznetsov. Russia's sole aircraft carrier has spent more time in refit than at sea over the last decade, plagued by fires, accidents, and maintenance nightmares. When operational, it carries Su-33 and Me-G, 2 9K fighters, but operational is generous for a ship that's been effectively non-functional since 2018. The ski jump launch system limits aircraft payload. The steam catapults never worked right, and keeping a Cold War carrier running costs more than building new surface combatants. Pyotr Veliky, nuclear-powered battlecruiser mounting everything from cruise missiles to anti-ship weapons to air defense systems, representing Soviet naval ambition at its peak. The Kirov-class design was meant to hunt NATO carrier groups and survive nuclear war, and Pyotr Veliky remains the only operational example. It's impressive on paper, increasingly irrelevant in modern naval warfare, but it makes Moscow feel powerful when it sails into the Mediterranean. Admiral Nakhimov, second Kirov-class battlecruiser that's been in modernization since the 90s, supposedly getting upgraded with modern missiles and electronics. The refit's taken so long that by the time it's finished, the new systems will be outdated. Slava-class cruisers. Guided missile cruisers armed with massive anti-ship missiles, air defense systems, and guns for engaging surface and air targets. Aging, expensive to maintain, and vulnerable to modern anti-ship weapons. Moskva's sinking proved that Cold War surface combatants don't survive modern missile strikes. Udaloy-class destroyers. Anti-submarine warfare destroyers, designed to hunt Western submarines in Cold War scenarios, mounting helicopters, torpedoes, and sensors for detecting subsurface threats. 8 remain in service, split between Northern and Pacific fleets, gradually deteriorating without proper maintenance. Sovremeny-class destroyers. These guided missile destroyers were built to kill NATO carrier groups with supersonic anti-ship missiles. Most have been retired or sold to China, with only a handful still operational. They're maintenance nightmares that break down constantly. Admiral Gorshkov-class frigates, modern surface combatants bringing caliber cruise missiles, air defense, and anti-submarine capability, represent Russia's current shipbuilding focus. 3 are operational with more under construction, and they're capable platforms when they actually work, which is complicated by sanctions limiting access to components. German diesel engines, Italian electronics, and Ukrainian gas turbines created dependency that sanctions exploited. Admiral Grigorovich-class frigates, Black Sea Fleet frigates mounting caliber cruise missiles and modern air defense, designed for operations in confined waters. 6 were planned, 3 built for Russia, 3 more built but sold to India, after Ukraine refused to supply engines. New Strashimi-class frigates, older frigates from the 90s that were meant to replace Soviet-era ships, but production stopped after 2 were built. They work, they're capable, but they're orphans in a fleet that moved on to other designs. Starogushti and Gremyashti-class corvettes, light surface combatants optimized for patrol and escort duties in coastal waters, armed with missiles and guns for engaging surface and air threats. Russia's building these steadily, because they're smaller, cheaper, and faster to construct than frigates or destroyers. Stealth shaping gives them reduced radar signatures. Buyan M-class corvettes, small missile corvettes that punch above their weight class by mounting caliber cruise missiles on vessels under 1,000 tons. They're vulnerable to modern anti-ship weapons, shallow draft limits where they can operate, but they're cheap and capable of launching missiles that can hit targets thousands of kilometers away. Karakurt-class corvettes, slightly larger than Buyan, with better seakeeping and more capable air defense, representing Russia's effort to build corvettes that can actually operate in open ocean instead of just coastal waters. Tarantul and Nanuchka-class corvettes, Soviet-era missile boats armed with anti-ship missiles, still operating in reduced numbers. They're obsolete, they're fragile, but caliber retrofits give some of them modern strike capability. Grisha-class corvettes, ancient patrol ships from the 70s that somehow keep operating in second-line roles. Light anti-submarine weapons and minimal electronics make them useful for patrol when nothing else is available. Molnia and Pauk-class patrol boats, small coastal patrol vessels for anti-submarine warfare and patrol duties close to shore. Limited capability but cheap to operate. Raptor-class patrol boats, modern high-speed patrol boats for coastal defense, special forces insertion, and rapid response. They're fast, maneuverable, and armed with machine guns and rockets. Moving on to amphibious forces. Modern amphibious ships designed to replace Soviet-era vessels carrying tanks, vehicles, and naval infantry. 2 are operational with more potentially being built. though construction's been painfully slow. They represent Russia's attempt at modern amphibious capability. Rapucha-class landing ships. Soviet-era tank landing ships that form the backbone of Russian amphibious forces. They can beach themselves to offload cargo directly, and they've been doing it since the 70s. Simple, functional, and Ukrainian missiles have sunk at least 2 Alligator-class landing ships. Even older amphibious ships from the 60s that are somehow still in service. They're obsolete, they're worn out, but Russia keeps operating them because building new amphibious ships takes time and money. Zubro-class hovercraft. The world's largest military hovercraft can carry 3 tanks and 140 troops at 60 knots across water and land. They're impressive, they're expensive, and most are in various stages of disrepair because maintaining hovercraft is a nightmare. Small landing craft for tactical operations, operating from larger amphibious ships or independently in coastal areas. Ondatra-class landing craft. Civilian designs militarized for transporting vehicles and cargo in shallow coastal waters where larger ships can't operate. Moving on to mine warfare vessels. Alexander Obukov-class minesweepers. Modern mine countermeasures vessels with fiberglass hulls to reduce magnetic signature, equipped with sonars and mine destruction systems. Few have been built, despite plans for more. Alexandrit-class minesweepers. Another modern design with slow production, representing Russia's struggle to build sophisticated mine warfare vessels. Yevgenia and Sonia-class minesweepers, Soviet-era mine warfare vessels still in service, using wooden and fiberglass hulls to avoid triggering magnetic mines. They work, they're basic, and the design's proven. Goria-class minesweepers, older design that's mostly retired but a few remain operational for training in low-threat operations. Moving on to submarines. Bore and Bore A-class. Russia's newest ballistic missile submarines carry 16 Bulava intercontinental ballistic missiles each, forming the sea-based leg of Russia's nuclear triad. 8 are operational, with more under construction, and these represent Russia's commitment to maintaining credible nuclear deterrence. Quieter than previous Soviet designs, but still louder than American submarines, they operate from heavily defended bastions in the Arctic and Pacific. Delta IV class. Older ballistic missile submarines carrying 16 R-29RMU missiles continue serving because replacing them with Bore-class boats takes time. They're loud by modern standards. They require extensive support infrastructure, but they carry nuclear weapons, and that matters more than acoustic signature when you're hiding under Arctic ice. Delta III class. Even older SSBNs that are mostly retired, with 1 or 2 possibly still operational in reserve status. They should be museums, but Russia's strategic deterrent can't afford gaps. Yasen and Yasen M class. Russia's newest attack submarines combine cruise missile strike capability with traditional anti-submarine and anti-surface warfare. The multi-purpose design lets them hunt submarines, attack surface ships, or launch Caliber and potentially Zircon missiles against land targets. 4 are operational with more building, representing Russia's most capable undersea assets outside the nuclear deterrent force. Akula and Akula II class. Attack submarines from the late Cold War that remain Russia's primary hunter-killer force, quieter than previous Soviet designs but still detectable by modern Western sensors. About 8 remain operational in various configurations, conducting patrols and training operations. Sierra I-2 class. Titanium hulled attack submarines, designed to dive deeper than conventional boats, expensive to build, and only 4 were made. 2 remain operational, proving that titanium construction works but costs too much for series production. Oscar II class. Cruise missile submarines designed to attack American carrier strike groups with salvos of Granite anti-ship missiles, though modernization is adding Caliber compatibility. Massive, loud, and built for a mission profile that may not survive first contact with modern carrier defenses, but they represent significant investment and capability. Victor 300 class. Ancient attack submarines from the 80s that should be retired, but a few remain operational. They're noisy, outdated, and kept running because replacing them costs money. Kilo and improved Kilo class. Conventional diesel-electric attack submarines provide quieter operation than nuclear boats when running on batteries, optimized for coastal patrol and defense operations. Russia's built improved variants with air-independent propulsion and continues operating older models, maintaining a mixed fleet of conventional and nuclear submarines. Lada class. Modern conventional submarines with improved electronics and quieter operation, supposed to replace older Kilos. Production's been plagued by problems with only 1 or 2 operational after years of development. Varshavyanka class. Improved Kilo variant being built for Russia and export customers, bringing modern electronics and weapons to proven diesel-electric design. Special purpose submarines. Russia operates several unique submarines for special missions, including the nuclear-powered AS-12 Losharik for deep-sea operations, BS-64 Podmoskovia as a mothership for mini-subs, and other specialized platforms. These exist for missions nobody talks about, from tapping undersea cables to deploying special forces to testing weapons. Moving on to strategic weapons. RS-28 Sarmat, the heaviest ICBM in Russia's arsenal, supposedly entered service in 2024, designed to carry multiple nuclear warheads, or the avant-garde hypersonic glide vehicle. It's meant to replace the aging R-36M Satan missiles from Soviet times, bringing more payload and penetration aids to overcome missile defense. Whether it actually works as advertised won't be known until it's used, and if it's used, nobody will be around to grade performance. RS-24 Yars, mobile and silo-based ICBM forming the ground-based leg of Russia's nuclear triad, deployed across Russian territory in hardened silos and mobile launchers that move to avoid targeting. It carries multiple independently targetable reentry vehicles, meaning one missile can hit several targets. RS-26 Rubej, intermediate-range ballistic missile developed to exploit a loophole in arms control treaties, deployable on mobile launchers for rapid relocation. RS-12M Topol-M, older single-warhead ICBM in both mobile and silo configurations, still deployed while newer systems gradually replace it. UR-100NUTTH, Soviet-era ICBM in silo configuration, reaching end-of-service life but still operational, because strategic deterrent can't have gaps during modernization. R-36M2 Voyevoda, the Satan ICBM from the Soviet Union that's been kept operational through sheer willpower and maintenance, carrying the heaviest warhead load in Russia's arsenal, until Sarmat replaces it. Avant-garde hypersonic glide vehicle. This boost glide system rides atop an ICBM before separating and maneuvering through the atmosphere, at speeds reportedly exceeding Mach 20. Russia claims it's invincible because the combination of speed and maneuverability defeats missile defense, and there's some truth to that. Current intercept technology struggles with hypersonic maneuvering targets. Production numbers are unknown. Operational deployment started in 2019, and it represents Russia's bet on penetrating American missile defense. Kinzhal air-launched hypersonic missile, essentially a modified Iskander missile launched from MiG-31K interceptors, or two Tu-22M3 bombers, reaching speeds around Mach 10 and hitting targets up to 2,000 kilometers away. Russia's used these repeatedly in Ukraine, and while they claim they're invincible, Ukrainian Patriot systems have intercepted at least some of them. The Kinzhal is less revolutionary than advertised. It's a fast missile, not a game-changer, but it's operational and being deployed. 3M22 Zircon, the scramjet-powered anti-ship missile, travels at Mach 8 and reportedly entered service in 2024, launched from surface ships and submarines with the mission of sinking NATO carriers before they can strike. If it works as advertised, it's a significant threat because the warning time's minimal and intercepts extremely difficult. Reality's probably between Russian propaganda and Western skepticism, and we won't know for sure until someone tries to shoot it down. P-80 Del Zero Onyx, supersonic anti-ship missile that's been in service since the 2000s, flying at Mach 2.5 with sea-skimming capability to avoid radar detection. It's effective against surface ships, proven in exercises, and deployed on ships, submarines, and coastal defense batteries. 3M54 caliber. These subsonic cruise missiles have become Russia's precision strike weapon of choice, launched from ships, submarines, and aircraft against land and naval targets. Range varies by variant, but extends to 2,500 kilometers with some models, and accuracy is good enough for hitting specific buildings. Russia's used thousands in Syria and Ukraine, proving the system works even if it's not revolutionary. 3M14 caliber, land attack variant with extended range for striking infrastructure and military targets deep inland from maritime platforms. K-101 and K-102, air-launched cruise missiles carrying conventional or nuclear warheads up to 5,500 kilometers, launched from strategic bombers operating in safe airspace. They're subsonic, they're vulnerable to air defense, but they let Russia strike without risking aircraft. K-55 and K-555, older air-launched cruise missiles from the 80s that are gradually being replaced by K-101, but still operational on Tu-95 and Tu-160 bombers. K-32, modernized anti-ship missile designed to attack carrier groups at extended range, launched from Tu-22M3 bombers at high altitude before diving toward targets. K-47M2, Kinzhal, the air-launched variant of the hypersonic missile already discussed, mounted under MiG-31K fighters for strategic strike missions. K-59MK2, precision air-to-surface missile with extended range for attacking ground targets from tactical aircraft operating at standoff distances. K-35U, anti-ship missile for tactical aircraft and ships, providing capability against surface vessels at ranges up to 260 kilometers. K-31P and K-31A, anti-radiation missile for suppressing enemy air defenses, and anti-ship variant for maritime strike, giving tactical aircraft self-defense and offensive capability. Iskander-M, short-range ballistic missile system deployed at the tactical level, launching missiles up to 500 kilometers with conventional or potentially nuclear warheads. Maneuverable reentry vehicles complicate interception, and Russia's used these extensively in Ukraine for striking high-value targets. The system includes both ballistic and cruise missile options from the same launcher. Tochka U. Older tactical ballistic missile that's being replaced by Iskander, but remains in service because Russia never throws away functional weapons. Less accurate, shorter range, but still capable of delivering high explosive or cluster munitions. 9. M729. 8. Ground-launched cruise missile that violated the INF Treaty, leading to the treaty's collapse. It's deployed despite arms control violations, because Russia prioritizes capability over international agreements. Bulava. Submarine-launched ballistic missile for Bore-class submarines, carrying 6 to 10 nuclear warheads with range exceeding 8,000 kilometers. Development was plagued by test failures, but it eventually worked well enough for deployment. R-29 RMU Siniva. Submarine-launched ballistic missile for Delta IV submarines. Liquid fuel designed from Soviet era that's still operational, carrying 4 warheads. P-1700 Granite. Massive supersonic anti-ship missile carried by Oscar II submarines and Pyotr Veliky battlecruiser. Designed to saturate carrier defenses with coordinated salvos. Each missile weighs 7 tons and flies at Mach 2.5. P-1000 Vulcan. Anti-ship missile mounted on Slava-class cruisers, forming the primary armament for attacking NATO surface groups. 16 missiles per ship represent enough firepower to threaten any surface fleet. 9 M96 and 48 N6. Surface-to-air missiles for S-400 and S-300 systems, with different variants for different engagement envelopes from short to long range. 40 N6. Extended range interceptor for S-400 kilometers against aircraft and ballistic missile targets, representing Russia's most capable air defense missile. 9 M311 and 9 M311. 1M. Surface-to-air missiles for Pantsir system, providing point defense against cruise missiles, drones, and aircraft at short range. 9. M338. Surface-to-air missiles for Tor system, engaging low-altitude threats with rapid reaction capability. R-77. 1 and R-77M. Beyond visual range air-to-air missiles for Russian fighters with active radar, homing, and range exceeding 100 kilometers for the M variant. R-73 and R-74M. Short-range infrared-guided air-to-air missiles for close combat, with extreme off-boresight capability thanks to thrust vectoring. R-37M. Ultra-long-range air-to-air missile for MiG. 3-1 interceptors, reaching out to 400 kilometers against high-value targets like AWACS and tankers. R-27 family. Medium-range air-to-air missiles in various configurations, including infrared and radar-guided variants, still operational on older fighters. K-25, K-29, and K-38. Air-to-surface missiles in various weight classes for tactical aircraft, providing precision strike capability against ground targets. S-8, S-13, and S-25. Unguided rockets for attack helicopters and ground attack aircraft, available in different calibers for different targets from personnel to armor. Moving on to small arms and infantry weapons. AK-12 and AK-15. Russia's current issue service rifles replace the AK-74M with modularity, improved ergonomics, and rails for optics. The AK-12 fires 5.5.39 mm, while the AKR-15 uses 7.62x39 mm, giving units flexibility for different mission profiles. They're better than their predecessors, but still, fundamentally Kalashnikov designs that prioritize reliability over precision. AKA-74M, the 5.45 mm assault rifle that's been Russia's standard infantry weapon since the 70s. Continues serving because millions exist in inventory and they work reliably in conditions that would destroy more sophisticated weapons. Simple, effective, and proven across decades of combat. AK-103, Alaska, 104, and AKM. The 7.62x39mm variants preferred for situations demanding better penetration and stopping power over the flatter trajectory of 5.45 mm. The AK-104 is carbine length for special forces and vehicle crews. N-94 Abakan. Advanced assault rifle with unique 2-round burst mechanism for improved hit probability, but complexity and cost-limited adoption to special units. AK-107 and AK-108. Balanced recoil systems reduce felt recoil and muzzle climb, improving controllability, but they never achieved widespread adoption. AS-VAL and VSS Vintores. Integrally suppressed rifles in 9x39mm for special operations designed for quiet close-range combat with subsonic ammunition. S-R-3M Vic. Compact submachine gun in 9x39mm for special forces. bringing suppressed firepower in a package small enough for vehicle crews and close protection. PP 19 Vityaz and PP 200 submachine guns in 9x 109mm for police and security forces, offering higher capacity and better controllability than pistols. PKM and PKP Pecheneg general-purpose machine guns in 7.62 x 54mm provide squad-level fire support that's defined Soviet and Russian infantry tactics for generations. The Pecheneg modernizes the PKM design with improved barrel and bipod, but both continue serving because the basic concept works. RPK 74M and RPK 16 light machine guns based on AK platforms provide squad automatic weapon capability in 5.45 x 39mm. The RPK 16 is the modern version with improved barrel and ergonomics. Cord and Cord M heavy machine guns in 12.7 x 108mm provide anti-material capability for destroying light vehicles, aircraft, and fortifications. Vehicle-mounted and tripod configurations give Russian forces heavy firepower. NSV-UTOs, older heavy machine gun being replaced by Cord, but still widely deployed because functional weapons don't get retired just because newer models exist. PKT, tank-mounted 7.62mm machine gun, coaxial with main guns on Russian armor for engaging infantry, and light vehicles, SVDA, Dragunov, and SVDM. The designated marksman rifle in 7.62 x 54mm gives Russian squads precision fire capability out to 800 meters. The SVDM brings modernization with improved ergonomics and optics mounting. SVCH, new bullpup designated marksman rifle designed to replace Dragunov, combining compact design with precision capability. SV98 and SV98M. Bolt-action sniper rifles in 7.62 x 54mm are for precision shooting, providing accuracy beyond semi-automatic designs. ORSIST 500, precision rifle in various calibers, including .338 Lapua Magnum, for special forces and designated snipers requiring extreme range capability. VSSK Vyklop, suppressed sniper rifle in 12.7 x 55mm for special operations, designed for silent elimination of targets at extended range. Chukovin SVJ, semi-automatic sniper rifle in 7.62 x 54mm. R, representing Russia's attempt at modernizing precision rifle inventory. ASVK Cord, anti-material rifle in 12.7 x 108mm for engaging vehicles, equipment, and fortifications at extended range. RPG 7V2 and RPG 7D. The anti-tank grenade launcher that's been blowing up vehicles since the 60s continues service because it's simple, effective, and costs almost nothing to produce and maintain. Modern PG 7VR warheads can defeat most armor that's not explosive, reactive, or composite. RPG-26, RPG-27, and RPG-28. Disposable rocket launchers in various calibers, giving infantry single-shot anti-armor capability without the weight of reusable systems. RPG-29 Vampire, heavier anti-tank weapon with tandem warheads for defeating explosive reactive armor. Proven effective against modern Western tanks in the right circumstances. RPG-30 Kryuk, anti-tank weapon with decoy rocket to defeat active protection systems, representing Russia's response to trophy and similar defensive systems. RPOA Shmel, thermobaric rocket launcher for attacking fortifications and bunkers with fuel-air explosions, devastating in urban combat. RCG-2, multi-purpose shoulder-launched weapon with interchangeable warheads for different targets from personnel to structures. 9. M133 Cornet, Cornet D, and Cornet EM. Anti-tank guided missile systems with laser guidance provide infantry and vehicle-mounted units capability to engage armor at ranges up to 10 kilometers. Tandem warheads defeat explosive reactive armor. 9 M13 Conquers M. Older wire-guided anti-tank missiles still in service with mechanized units, effective against armor, despite dated guidance. 9 M115 Metis M. Portable anti-tank missile providing precision capability to infantry squads, lighter than Cornet with reduced range. 9 M120 Ataka. Helicopter and vehicle-launched anti-tank missile with laser guidance, primary armament for attack helicopters. 9K38 Igla and 9K338 Igla. S. Manned portable air defense systems give infantry the ability to engage helicopters and low-flying aircraft with infrared-seeking missiles. 9K333 Verba. Newest manpads with improved seekers, longer range, and enhanced resistance to countermeasures, representing Russia's answer to modern helicopters with infrared countermeasures. 9K32 Strela, 2 and 9K34 Strela. 3. Older MAPDS still in inventory with reserve and militia forces. Basic infrared guided missiles for low altitude threats. AGS 30, and AGAS 40 Balkan. Automatic grenade launchers provide infantry with sustained indirect fire capability, throwing 30 or 40 grenades at targets up to 2,500 meters away. Volume of fire compensates for limited accuracy. GP 30 and GP 34. Underbarrel grenade launchers mounting on AK rifles give every infantry squad organic indirect fire capability with 40 grenades. The GP 34 is the latest with improved mounting. RGM 40. Hand grenade replacing older RGD5 and F1 designs with modern fusing and improved fragmentation. RGN and RGO. Offensive and defensive fragmentation grenades with dual mode fusing, providing Russian infantry close combat firepower. F1, defensive fragmentation grenade dating back to World War I that continues serving because the basic concept works. RDG 5, offensive hand grenade designed for use in close quarters where fragmentation would endanger friendly forces. RKG 3, anti-tank hand grenade with shaped charge for engaging armor at close range, still useful against light vehicles. PMM and PM Makarov, the 9x 180mm pistols that served Russia since the Cold War, gradually being replaced but still widespread. Yaryan MP 443 Grach and PYA, modern 9x 190mm Certus pistols, bringing better capacity and ergonomics, though distribution to frontline units remains incomplete. SR-1 Vector and SR-1M Gyurza, specialized pistols in 9x 21mm for penetrating body armor, developed for security and special forces. PB 6P9, suppressed pistol in 9x 118mm for special operations requiring silent capability. GSHA 18, polymer frame pistol in 9x 19mm, designed for modern military service, though adoption's been limited.